Hi, everyone. My name's Amanda Archibald, and I wanted to share with you a longevity gene hack. Now, many of you know that my expertise is in the field of genomics, and what that means is that I help you and clinicians and people around the world understand how genes work in our body, how they impact, for example, the type of exercise that benefits you, how they impact personality, characteristics, very importantly, how they impact how you respond to different nutrients in food, which nutrients you may need more of, whether you need to change how much saturated fat you're eating, et cetera, et cetera. That field also encompasses an interesting subfield called nutrigenomics. And nutrigenomics is how we can use food or information in food that we call bioactives to turn genes on and turn genes off. So it's an enormous field. It's an incredible field of work. And through many years of learning, you start to see patterns and you start to pick up on really cool pieces of information, one of which I'd like to share with you today, and that is how to empower two genes that work together called SIRT-1 and AMPK. So I'm going to navigate you through this roadmap that I created, and of course you can download this. And I create roadmaps to help you take a lot of complex information and put it into a logical one-pager that summarizes everything and it helps you kind of find your way through the information. So SIRT-1 and AMPK are really, really useful genes because when we turn them on, and in fact, they turn each other on. When you turn SIRT-1 on, it activates AMPK. When you activate AMPK, it also kicks SIRT-1 into gear. So they're kind of like siblings, if you will. But when you turn these genes on, there's a huge number of benefits that you get from them, which would be associated with longevity. So we're going to talk about how you turn them on, and then I'm going to talk about why they will be associated with longevity. Okay, so how do we turn them on? How do you empower these genes? You can download the roadmap and follow along yourself. So the way that we turn these genes on and what they respond to is in a lower energy environment. What that means is if you overindulge or you eat until you're overflowing and you can't move, you actually turn these genes off. What they respond to is, like I said, a lower energy environment, which means when you're actually hungry, or you can trick your body, if you will, into feeling hungry, which is a natural state. You're really not tricking your body. But when we use the idea of time-restricted eating or intermittent fasting, what we're actually doing is creating an energy deficit for your cells, or you're activating those hunger cues. And when you do that, you activate SIRT-1 and AMPK. The other thing that we know, which is really interesting when you think about it, is that resveratrol, which is a phytochemical or bioactive we find predominantly in red grapes, also activates these genes. Now, if you think about it, if you think about longevity, and well, we've learned a lot about centenarians of people who live to be a healthy, ripe old age. Some of the initial research and continued research is from the Mediterranean. And many, many people in the Mediterranean will accompany often their evening meal with a glass of wine, often red wine. And so you think, oh yeah, Mediterranean, glass of red wine, centenarians. Is it cause and effect? Is it okay if you drink a little glass of red wine, you'll live a longer life? It's never just one thing. But it's kind of interesting that resveratrol is something that appears almost daily or extremely regularly in Mediterranean countries. Okay, now do they drink white wine? Of course. So just a little connection there. So we have energy deficit or a time-restricted eating, or the concept from Asia or Japan have ariachi-bu, which means eating until you're 80% full, means you're not overindulging. So you push away from the table, right? Before you're full, eat your 80% full, leaves your body looking for something more. But by so doing, you can set in motion the activation of these longevity genes, SIRT-1 and AMPK. So what is so beneficial about these genes? So what's beneficial is they activate and deactivate other very, very important genes. So we're going to go through them. When you activate SIRT-1 and AMPK, you activate a gene called FOXO. What FOXO does is activates your body's own endogenous antioxidant system. I call them super antioxidants, catalase, CAT, or SOD, superoxide dismutase. They are exponentially more powerful antioxidants than the ones you get in your diet. So you have to prompt your body to produce these super powerful antioxidants. And we do that by activating genes that can actually activate the production of these antioxidants. So you want to think of them like a fire hose in your cell. They're putting out very corrosive free radicals or reactive oxygen species. If we don't take care of these reactive oxygen species, they can cause a lot of damage to your cells and tissues. Damage to cells and tissue builds up over time and can lead to early onset of some of the diseases you're very familiar with. So you want a diet that's replete in antioxidants, or you want to set in motion a process by which you activate genes that produce these antioxidants. So when you activate SIRT-1 and AMPK, you can prompt your body to produce its own antioxidants. The other thing that the longevity hack by activating SIRT-1 and AMPK is you activate a master gene called PPARG-C1A. This is a master gene that helps you turn on your fat burning mechanisms. We call this beta oxidation. You know, the most of your energy in your body is stored as fat in your cells. So most of us would love to have a long burning, fat burning mechanism, right? We want to kind of get rid of any excess fat we don't want, but also we want to access fat if we're in a long race, so we have to go a long period of time without food. We want to access those fat stores, and this gene helps you do that. The other thing that's powerful about this gene, there's two things actually. The first is it helps your body produce new mitochondria. Mitochondria turn over about every 30 days. You need to replace them. You need to get rid of the old. You don't want them hanging around because they can be quite corrosive. And you want to bring in the new. Your mitochondria are the power plants of your cells. You want new ones. You want them to work efficiently. If you have inefficient mitochondria, you're going to pay a lot more for your electricity and your gas than if you have efficient ones. Think of it like that. PPARG-C1A also activates another super important gene called NRF2. NRF2 really isn't a gene. It's actually what we call a transcription factor. And when we activate it, itself activates a whole bunch of other genes. It is a very powerful molecule in your body. What does it do? It also helps your body produce those key enzymes, superoxide dismutase, catalase, and glutathione peroxidase. I just call them enzymes. They're actually antioxidants. Those are the ones you have to get your body to produce. You do that by turning on genes that do that for you. NRF2 also turns on very powerful genes that produce enzymes to help you detoxify or get rid of molecules that are toxic to your body. They can be environmental, they can be hormonal, they can be a result of taking medications, et cetera, et cetera. You need to turn on your body's detoxification mechanisms, and NRF2 does that beautifully. The other thing that NRF2 does is it turns down or turns the volume down on pro-inflammatory genes such as TNF-alpha, IL-1, IL-6, IL-8. Now, understand that the body is always in a state of balance. We need to have a robust immune response to take care of foreign substances, things that are invasive to the body that we don't need to be there. But the challenge is some of us end up with that immune system turned on or just turned up and humming away every day. That also is extremely fatiguing and corrosive to the body. So you need a shutoff valve. And our NRF2 does that. How do you activate NRF2? By activating SIRT-1 and AMPK. Now, there's other ways to activate NRF2, but today we're just connecting to the power of SIRT-1 and AMPK. Two other things that are really noteworthy about when we activate these genes, then I'm going to put that in context for you in terms of longevity. When you activate SIRT-1 and AMPK, they help the body shut down poorly functioning and disruptive cells. We call this apoptosis, or it's programmed cell death. All cells have a lifespan and they are pre-programmed to die. Sometimes cells hang out, and when they hang out and they don't die completely, they just become very kind of like a drag on the system, and they become very disruptive. They become almost like a metabolic firing squad of those reactive oxygen species. The more reactive oxygen species you have in the body, the more damage you're going to incur, the more likely you are to succumb to, or basically induce the onset of chronic diseases like heart disease, high blood pressure, diabetes, even cancer, and on and on. So we want to make sure we get rid of those reactive oxygen species or balance them out, want to tame or turn down the immune system. And we certainly want to get rid of cells that are no longer able to do their job. They kind of lie around in the body and rot and decay, if you will. Not good. The final most powerful aspect, or very powerful aspect, of activating SIRT-1 and AMPK is they will turn down the volume or deactivate another very powerful gene, NF-kappa B. NF-kappa B is a master switch in your immune response mechanism. When you turn on NF-kappa B, it basically signals to all the Army, the Air Force, if you will, the National Guard, to come over and help defend your body. Again, appropriate when we need that level of immune response, but in many people, we keep on kind of knocking on the door of NF-kappa B to come and take care of invasive molecules or whatever is kind of floating around that is asking your body to kind of stand up its defense mechanisms. An immune system that's permanently turned on is a very, very disruptive immune system. It weakens the body. And this is where we see the onset of autoimmune diseases, which some people suddenly, they wake up one day and say, where on earth did this come from? Oftentimes it comes from a long underlying on switch in your immune system. So when we turn on SIRT-1 and AMPK, we can turn off or turn down the requirements for immune defense. So what I've gone through then is on the left-hand side of your roadmap here is a number of genes that help manage kind of the stability of your body. They help manage your immune defenses. They help mobilize your antioxidant defense. They help you efficiently burn energy. They make sure that your power plant is turned on and healthy and doing its work. And all of these aspects that I've talked about are consistent with longevity because they're helping your body work in a harmonious way, okay? They're sort of really helping your body live day to day without these sort of outlandish attacks or kind of overreacting to the world we're living in. So when we can have that kind of harmony, we call that homeostasis. I was going to say hormesis. It's not that, it's homeostasis, which is balance. That is consistent with longevity. So you have a huge key as to how powerful SIRT-1 and AMPK are. But there's more. There's more to the benefits of SIRT-1 and AMPK that connect directly with longevity. And that is this, that when you turn on SIRT-1 and AMPK, you by default turn off mTOR. And in the kind of biohacking and longevity community, mTOR gets a lot of attention. So let's talk about the benefits of turning off mTOR. But what I think it's really important before we talk about the benefits is, why would you have mTOR to start with? Well, mTOR is a very important molecule, if you will, in that it's a growth regulator, and it controls a lot of anabolic, so building, and catabolic breaking down processes in response to nutrients. So if you think about it, it helps infants grow. For babies grow, it helps people grow. Important, right? You need to stimulate those, what we call anabolic or building mechanisms, but we don't want to keep building, right? I mean, there's an end point to building. So one of the ways to think about the balance then is that mTOR is required. You can think of it as good for muscle building, but bad for controlling outrageous growth or out of control growth, such as with cancer or replicating oncogenic cells. So you want to build muscle, okay, to a certain extent, but you don't want to grow cells. So it's that fine, we don't want to grow cancer cells. So it's that fine balance. So we want a control mechanism, right? So when you turn on SIRT-1 and AMPK, you offer a control mechanism because you can turn off mTOR. One of the huge benefits of turning off mTOR is you turn on a process called autophagy. Autophagy you want to think about as being your recycling mechanism. So why would we have a recycling mechanism? Because recycling enables your cell to sort through debris and toxic waste product and get that ready to be removed from the body. But it also sorts through the useful information that the body can recycle. So autophagy in many ways is attached to a survival mechanism, in that if you are not able to eat for a number of days, your body needs to be able to sort through and say, okay, I need that glycerol backbone for a fatty acid. I need those 2 amino acids to build this protein. So it's a sorting mechanism, recycling what the body can use, pretty important if you don't get to eat for a few days, but getting rid of substances and molecules that are toxic, that the body has no use for. If we continuously have a situation where the body can't rest and sort through, then you end up with a toxic waste dump. So we want to enable autophagy. We can enable autophagy by turning on our SIRT-1 AMPK mechanism or circuit that will turn down mTOR and allow your body to do the recycling and the repair work that is needed. If you don't recycle and repair, you are a toxic waste dump. People don't live long in a state of toxicity. It causes early onset, a very debilitating disease, and potentially early demise or death. The other thing that we benefit from when we turn down or turn off mTOR is you turn on key metabolic processes. You help your body preferentially shift to its fat burning mode, beta oxidation. It prefers fat over carbohydrate. It will preferentially seek out your fats in your adipose tissue and burn those. Turning off mTOR turns on ketogenesis, okay? Something that many of us strive for. Ketogenesis is a very efficient burning or fuel burning mechanism. And gluconeogenesis, which is the production of glucose from amino acids, or glycerol, which is the backbone of fat. So basically, you're turning on a much more efficient fuel burning mechanism for your body. Turning off mTOR or getting that balance is really, really turning on a highly efficient mechanism of working, a production system for your body. So we want to keep mTOR in check and turn it off as much as we can. So then the final thing is like, oh my gosh, if we don't turn off mTOR, if I don't activate SIRT-1 or AMPK, what would turn it on? If we don't turn it off, how do we turn it on? What turns on mTOR? Because we want it turned off most of the time. Overnutrition, overindulgence. So eating too much, going back to for second and third helpings, or overloading your plate at the buffet bar, or overloading your plate, up ordering at breakfast time, what have you. mTOR loves a ton of calories. What else turns it on? Being significantly overweight or unfit. So really important here. People can have higher BMI, body mass index, but be very fit. So let's be careful not to judge this by body weight. You could be super fit and way more than the person next to you, and you'll still be able to turn mTOR off. But if you overindulge, eat too much, you're overweight, you're not moving around, you've got mTOR turned on, which means you're not going to be an efficient burner of adipose tissue. Elevated blood sugars, so persistent intake of carbohydrate, or poor utilization of carbohydrate, which often comes with being overweight. Not only does elevated blood sugar keep mTOR turned on, but also over a long period of time, you're going to develop insulin resistance. So elevated levels of insulin will also keep mTOR turned on. We also know that certain amino acids, particularly what we call branched chain amino acids, isoleucine, leucine, and valine, can also turn mTOR on. So what you want to think of with mTOR is what keeps it turned off or turned down are the exact mechanisms that turn SIRT-1 and AMPK on. So if you eat until you're 80% full, if you fast overnight, if you follow a time-restricted eating window or an intermittent fasting process or routine, in which you can also bring about by exercise too, right? Exercise can create an energy deficit. So anytime you can create an energy deficit, which is the opposite of overindulgence, you will turn on SIRT-1 and AMPK. And you know that those genes will turn on a whole host of other genes that help your body harmonize with its natural processes, harmonize with genes that help you take care of inflammation, oxidative stress, that help you get rid of things that are toxic to your body, that help keep your immune system in check, all of which are conducive to longevity. So my longevity hack for you today is get to know how SIRT-1 and AMPK work, because they will work beautifully in your favor. I hope you enjoyed this.